so how did we do with that? Did you get them? Any questions on any of those? Did the last one get you? That's the one that's gotten everybody all day today. This is just what proportion of all subjects had both of these conditions. So a yawn seed planted and yawned would be the 10 out of all 50. This is proportion of all subjects, not just the people that yawned or the people that were planted. It's the ones that have both. Okay, so let's look inside and see how are we going to use this to do some inference. So, if we are looking at a hypothesis test, are we dealing with proportions or means? What did you say first? I think you said proportions. Good job. So this is proportions. We want to know how many out of each group yawn. So what proportion of each group? We have two groups, so it's going to be a 2 proportion. Is it going to be T or Z? Z. Good. So that's the name of our procedure. Then we need to write some hypotheses. HO and HA. Which one of these is always an equal sign? HO. Good job. So we're comparing two proportions. So both of them are going to be P with some subscript. We need one group to be the ones that are seeded with a yawn and one to be the group that was not seeded with a yawn. So S and N, is that what I heard? Yeah. Okay. So seeded and not seeded. So HO is going to be that those are equal. And HA is going to be some sort of inequality. Now the hypothesis, what they believed was true, is that people are more likely to yawn if they see someone yawn. So that's the seeded group should be more likely. So what is going to be my inequality here? Greater than. Good. Then we need to define these parameters. So I'm going to define P sub S is the true proportion Hello. Okay, so this is the true proportion of the seeded yawn group. That actually yawned. P sub N is the corresponding proportion for the non-seeded group. Are we feeling okay with that part? Writing hypothesis, defining parameters. So, next we need to check some conditions. Our conditions are very much like what we had for one sample. We have two conditions. Who can tell me one of them? Random assignment or random selection of subjects. What's the other one? The size. We want to know, is the size large enough for at least what? There you go. 10 failures, 10 successes. That's what we're looking for. So for the randomization, they didn't randomly choose the subjects because they just took whoever was walking by and said, sure, I'll do it. But what they did do was they randomly decided which ones would get the seated yawn and which ones didn't. Okay? So treatments were randomly assigned. So now we want to check the large enough. So we need to check for each group. So I'm going to check the seated group. In that group, there were 10 that yawned, and there were 24 who didn't. So both of those are at least 10. So that one's good. Then I need to check my non-seated group. So there I only had 4 that yawned, and I had 12 that didn't. So here's where we have a bit of a problem because I need at least 10 of each. I have it here in the didn't yawn, but this one is less than 10. So because of that one, my conditions are not met. So what do we do with that? Do we just stop and say, okay, we can't do this problem, go on to the next? No. We do not do that. What we will do is we'll say, well, this condition was met, this one was fine, this one was okay, but it's just that one thing. So what we do is we say we proceed with caution. And you go ahead and finish it. If they're asking you to finish it no matter what. You're just going to make a note that I'm going to be cautious with my results because my conditions weren't really met, but I have enough information I can do the test, but I'm just not going to think of the results as really reliable. And then we get down here to this do the math. And we get this formula that looks all crazy. And then we go, oh, that's nice. We're going to use our calculator. So what this is doing is this is saying the difference in our sample proportions compared to the difference in the population proportions. Well, this population, we've said up here that we are going to think that it's equal, these are the same, unless we have evidence that they're not. So if we think these are the same, then this difference should be 0, because they're the same. This is saying, is the difference we have in our samples enough of a difference to say they're not the same? That's what we're looking at here. So that's why you see it written like that, is because we're comparing two values. So when we put this into our calculator, we're going to go back and we're going to look for this 2-prop-z test. That's what you're looking for in your stat menu. So right there, number 6, 2-prop-z test. That's the one we're going to use. And then our X1, that's how many yawn in our seated group, and then N1 is how many were in the seated group. And then our X2, this is how many yawn in the unseated group, and this is how many were in that group. And then our hypothesis, our HA, said greater than, so that's the one we select here. Now, typically before I even hit calculate here, I write down the numbers that I put in. That way I'm making sure I'm showing everything that I put in the calculator. So I'm going to go over here and say X for seated is 10, N for seated is 34. X for not seated is 4, N for not seated is 16. So that way everything is written here that I put into the calculator. I don't have to write this down because it's already in my HA. Okay, that inequality I've already written as HA, so I don't have to write that again. Then we will calculate, and we get a Z critical value here, or a Z test statistic, and we get the P value. So I'm going to write those on my paper. So those are the two numbers that I need for my output. So, which of these values do I use to make a decision? P value, good. What do I compare that with? The alpha, which they didn't tell us, so we used 0.05. Okay? So here I'll say the P value of 0.3729 is greater than an alpha of 0.05. So what decision do I make? Do I reject HO or do I not reject HO? Right. Since the P value is higher, I do not reject. Okay, so I'm not rejecting. So now I have to decide in writing my conclusion, either I have evidence or I do not have evidence. Which one do I do if I'm not rejecting? Not have evidence. Good. That the proportion of, this is kind of long, sorry. The proportion of subjects seated with a yawn that actually yawned is higher than the proportion of unseated subjects. These are a little bit longer because you have to describe two different populations in context whenever you're writing it. Say this one compared to this one, and write all that out. Questions on this one? Anything in that example that's confusing? Are you seeing how similar it is to one sample? Hopefully you're seeing a lot of similarity. Yes, Ms. Kimberly, we are. Thank you. Okay. So, on the next page, we're going to do a confidence interval. So now we're going to use that same data confidence interval. So, here, when we're doing a confidence interval, we're still doing two proportions. We're still looking at a Z, but now instead of test, we say interval. Okay? So, two proportion Z interval. So, for our conditions, over here, we checked random and large enough by checking the counts to see if there were at least 10 in each one of success and failure. How does that compare with the conditions that need to be checked over here? They're the same. So I'm just going to write same as this over here. Unless you want to write them out again, and you're welcome to do that. But we just wrote them on the other side of the paper. We can still see them. So in our do the math, this is where we're going to go into the calculator. So we're going to do, now we're going to do 2 prop z int. So 2 proportion z interval. And when we go to put this in, you should notice that these numbers are already in there for you, because the values that we put in to do our z test come right into this one for our z interval. Okay? So this x1, n1, x2, n2, all of that is the same as what we had before. But you still need to write on your paper. So x seated is 10, n seated is 34, x not seated is 4, and n not seated is 16. And the tallest confidence level is 95%, so that's our C level. And then we're just ready to calculate. And that's our values. Now, we're dealing with 2 proportions. Proportions are always values between what 2 integers? 0 and 1. Okay? So then how did we end up with a confidence level with the negative number? Any ideas on how that could happen? What in this equation could allow it to become negative? Plus and minus could do it. What else could do it?
Oh, when it was less than 10.
I mean, no. I was trying to think of where that would happen. No. What about this part right here? What's going to happen if P1 is bigger than P2? If P1 is bigger, it's going to be positive. But if P2 is bigger, it's going to be negative. So we end up with one negative and one positive. That means this is saying it could be that this group is more likely to yawn. This says this group is more likely to yawn. So what it's saying is we really can't tell which group is more likely because it's so close. Okay? So when you are doing a 2 proportion test, it's okay if you get a negative. It's okay if they're both negative. That's just showing conclusively that this one's going to be bigger than that one every time. That's what we're expecting to happen. If it's all positive, then that's saying P1 is bigger than P2. That's what we expect to happen every time. But if they're each one positive, one negative, it's saying it could go either way. We're not really sure. Does that make sense to you? Okay, so it all goes back to that subtraction part right there. So what this says is we are 95% confident that the interval that the interval from first value to second value contains the true. Now this is where it's slightly different than what we've done before. Instead of just saying the true proportion of whatever. Now, since this is a subtraction, we're talking about the true difference in proportion, because that point estimate is the difference of the two. Okay? So this value, that's our point estimate, it's the difference in them. So when we write it out, we're going to say it contains the true difference in proportions. seated and non-seated groups. So that's really the only thing that's slightly different is in our conclusions. On hypothesis test, you need to describe each one. And on this one, you're going to talk about the difference in proportions. If we were doing means, it would be the difference in meanings. Okay, last question.
Pardon teachers for the interruption. The following is an important message to all who will be attending the prom tomorrow night at the Glenville Convention Center from 9 to 12. Be sure to bring your Jinx High School ID to the dance, and outside guests must also present a photo ID to be admitted. To ensure your admission to the dance, please adhere to the dress code listed in the student handbook. In addition, suggestive dancing or dancing considered inappropriate by a chaperone or a principal will not be permitted and may result in being escorted out of the dance. Please remember that you will be greeted individually by a school administrator when you enter the dance. Also, campus police officers, administrators, and Providence Canine Services will be in the parking lot and drop-off points to randomly check vehicles. Anyone whose behavior, appearance, or breath smell indicates the possibility of alcohol or other substance use will be taken to a room where a breathalyzer and or field sobriety test will be administered. If alcohol or substance use is confirmed, the student will not be permitted to attend the dance and parents will be contacted to come and pick up their student. Students will also be disciplined according to school policy. Of course, it is our hope and expectation that everyone will conduct themselves appropriately and with the class that Jinx students typically display. We hope you have a safe and wonderful prom weekend. Have a great day.
Okay, so hopefully you already got this written down or are writing it. Since 0 is contained in the 95% confidence interval, that means we cannot say there's a difference. Okay? And since we did not reject HO, HO says there is no difference. They're equal. So those things match. Okay? We're saying 0 is a plausible difference between the two. This is saying the difference is 0. So those are agreeing on what's going on. So sometimes you'll be given a hypothesis test and be asked, is 0 contained in the confidence interval? Or you may be given a confidence interval problem and say, does this show significant difference between these two? So it's just, is 0 in there or is it not? Is what you're looking for. Okay, make sure that goes in there. My apologies, no problem set today. You guys don't have homework. But you do need to study so you're ready to do those test corrections next week.